So what is dimension? And now this dimension has nothing to do with the dimension in case of space measurement. In the chapter of dimensional analysis, the word dimension has a very different dimension, or to say different meaning altogether. So we have something called fundamental units of measurement, right? Okay.
Yes.
So I'll start with even before dimension. Let's talk what is measurement. How you measure something?
We compare it with a certain standard predefined length that we predefined thing of the same dimension that we know.
Correct. So it is an act of comparison. It is an act of comparison between unknown and standard. So what is standard? What is standard?
Predefined quantities that are taken as a reference.
Correct. So standard are like, of course, it's a well-defined. Basically, these are definitions, and as per the definition, we have some sort of standard. You can say a physical unit kept somewhere in the Sevres, France, right? So every, few years there is a weights and measurement conference which is held in Geneva, and there's a place called Sevres, France, okay, in France. So in that place, people, scientists from all over the world, they come together and they represent their respective countries, and then they mutually agreed upon something. What they agreed upon is called standard. They tried to modify the definition over the years, and they have been trying. And definitions are something which is indestructible and reproducible. So there are two things about the standard: indestructible and reproducible. So reproducible means, let's say there's the World War, and if you remember that in class 9th you studied 1 kg is a platinum iridium cylinder kept between the vault. Okay. So possibly platinum iridium is the least corrosive alloy. So over the maybe 1,000 of years, it will not corrode, and so it will continue its value, the measurement intact for a very long time to come. But there is a issue. These objects which we have taken as a standard, this can be destructible. You can destroy it by the bombarding, by doing something. Okay. So every unit of measurement should be kept very secretly and very you can say in tight security, so that nothing can destroy when some world war is happening. Now the question is why it is so important. Okay, the answer is simple. The world, the civilization, you can say across every continent, the purpose of civilization is to do the commerce and trade and exchange the scientific development, technological transfer, and for every exchange there is some value associated, and those values, let's say for currency example, for currency you use gold as a reserve, and against the gold reserve of every country you can print the notes. Okay, so gold is, of course, it is used for jewelry making in India, but in most of the country gold is only a way to create currencies. And the value of the, you can say, the currency depends on how much gold reserve you have per capita. Okay, so there are some rules and regulations, and depending on how much gold reserve you have, you can create equivalent currency, and that will decide that which currency is going to be more expensive than which other currency. So that's how we decide the currency relation, okay, among countries. And this value exchange is important so that the commerce and trade is fair for everyone. And therefore, the decision to create something standard which can be followed by all the participating countries is equally important. So over the period of time, we had some other definition, like the length was distance between some fraction of distance from the North Pole to the equator. And if you divide into certain number of parts, that we call uh, simply 1 meter. Then later on, we change that, okay, this is not good. So we said, okay, no, in the krypton atom, the transition of electron creates some sort of wavelength. And if you count those many number of wavelengths, maybe something, there is a number, then that number will give you 1 meter. Now, we always try to go for such a definition which are indestructible. Of course, you cannot destroy that. Okay. I mean, it is not like that after the World War, the atom will go away. I mean, still we can have atom and those definitions are intact. So we can recreate the length dimension. So we can reproduce it. So over the time, we always try to, create a better definition, which is non-physical in nature. So earlier we started with the physical definition and we made something like a platinum iridium cylinder. We took some platinum rod and we called 1 meter. And then we send the replica to every participating country of the same. And then that replica was having the second copy, you can say. And that second copy is sent to various state of the country. And in every country, and mostly there's something called the Weights and Measures Bureau there also. They take care of the local trade and commerce. So the weighing machine they use must be, I mean, following certain protocols. And if it is violating, it's a kind of illegal activity. I mean, you may be put behind the bars for the same activity. So in India, the control is under the National Physics Laboratory in Pusa Road, New Delhi. That is the, you can say, headquarter, you can say, for the weights and measurements, and it will kind of set for some protocol to be followed by each and every state. Then they have some local, you can say, center where every shopkeeper they have to go and check their equipment every few years. So there is a license which is issued to the shopkeeper also that they must follow. So this is followed not very strictly, but to an extent it is being followed strictly. If you are doubtful about someone who is having the malpractice, you can complain about it to the Weights and Measures Bureau, and then they will put behind the bars or there will be huge penalty. So measurement is, of course, an act of comparison, and the way to create this standard is something which is indestructible, so that we can reproduce it as and when required, even during the emergency situation. Okay, if there is a collapse of civilization, if there is a rebirth of civilization after a few thousand years, then they should find, if they find the article about the definition, probably they can recreate the newer civilization very fast and very quickly. Okay. So that's the whole purpose of standard. Now we have something called fundamental units. So standards are basically well defined physical quantities. Okay. So generally the fundamental units are those quantities which we take as a base, and the other quantities we measure according to this these physical quantities. Now sometimes it will be contradictory because these definitions came long time back. So let's say the definition of ampere came as a force between the two current carrying parallel wires, and then from there the ampere got defined as a fundamental unit. But now later on we came to know that current is nothing but the flow of charge. So instead of changing that to charge as a more fundamental, which we know today it's more fundamental, we still stick to the ampere as fundamental unit of current. And in fact, we define charge in terms of current, not the vice versa. So we have 7 fundamental quantities, and we have other derived quantities. So in fundamental, what we have? Mass, kilogram. These are SI units. So SI stands for System International, right? It's again French word. In English, you can say International System of Unit. So it's a ISU. Anyway, in India, what we have is ISI mark, the trademark. Okay, again, those are connected with the weights and measures only. So for mass, it is kg. And what is the dimensional relation? I mean, formula for mass. So we write capital M, and we write the symbol between the square bracket to represent its dimension. I'll come to what is the dimension. I'm just trying to keep it short. Next is length, meter, dimensional, that is time, seconds. What else? Tell me, guys.
Temperature.
Temperature, Kelvin. Okay. So we write by capital K. And the unit we can address. So you can use K also, but then we are theta. Then next,
Ampere.
yeah, current.
Current.
So ampere. You can use I, but we can use two symbol. Either you can use A also, that's totally okay. Or sometimes people use I dimensional. What else?
Mole.
Sir, mole.
Yeah, mole become, of course, amount of substance. So we write MOLE mole, but we write as what else?
And
Luminous
intensity.
Luminous intensity. Candela.
Candela.
Yes.
So we write as capital CD or small CD. I think it's
So small seed.
small CD. Yeah, I think it's
think
small.
yes.
Yeah. Anyway, you can just check it out. Although candela is not going to be used here. And then we have the two supplementary unit, right?
Radian and steradian.
So plane angle, radian, so you can say RAD and steradian, which is the solid angle.
Solid.
Yes, sir. So derived quantities. So derived quantity means you derive from the fundamental. So you take some, combination of this fundamental and you create the quantities with some physical meaning. So we call it derived quantities. So fundamental quantities are defined. You cannot derive it. And derived quantities are like derived from the fundamental. That's why it's called derived quantities. So I'll just keep it short. The entire mechanics we can take care by the
MLT.
so MLT is more than enough to get, to derive anything from mechanics. But the moment you enter to the electrostatics, current, capacitor, EMI, AC, whatever, then something else will come. Okay. So some popular derived quantities, let's call. Okay, we can start from here. So derived quantities, let's start with the velocity. What is the definition? Just think of a unit, meter per second. Meter per second. Simple. And to make it more precise, you can write as m0 if nothing is there. Okay. And then acceleration. Meter per second square. And once you know the velocity and acceleration, you can find force. Let's call momentum first. Momentum, how much? Tell me, guys, quickly.
MLT minus.
Kg meter per second. Kg meter per second. Okay, that's it. Force, mass into acceleration, so m LT minus 2. Work, energy, torque. All are R cross F. Torque is FR. Force into displacement, again FR. Energy, again work is energy. So all are same dimension. What is the dimension? Just multiply force
L
with L.
square.
L square T.
Okay. Moment of inertia. A square. Okay. What else? Force. Angular momentum. MVR. MVR. Correct?
Yeah.
Impulse. Force into time. So force in time is also changing momentum. So it's again momentum. Correct? So impulse is same as, because they are
Moment.
equal to each other. Right? Impulse is changing momentum. So dimensionally they are same. Okay. What else? The famous one. Universal gas constant R. So it is PV by NT. The dimension of PV is energy. Always remember this is energy, right?
Yeah.
And temperature becomes Kelvin inverse, more inverse. Okay. Planck's constant equals to h. So it's anyway, h is energy into time. So the dimension of h is energy into time. Energy is how much? T minus 2 into T minus 1. Okay. Which is same as angular momentum, isn't it?
Yes, sir.
And that's logical
Yeah, P by lambda.
because because we know that okay, angular momentum is nh by 2 pi from Bohr's quantization. So L and H are having same dimension. N is number dimensionless, 2 pi is dimensionless. So if you remember this, angular momentum is same as the Planck's constant dimensionally, right? So let's take something. Universal gravitational constant. Capital G, how much? So if you recall the Newton's formula, F square by so F equals to G M1 M2 by R square, right?
Yes, sir.
So it is F square by M square. M L T minus 2 L square. What's the answer? Okay.
Yes, sir.
Boltzmann constant. Tell me. So we know the relation energy equals to energy, kinetic energy is proportional to KT. This one factor.
Yes, sir.
So half KT represents the energy, isn't it?
Yeah.
So
Yes,
the Boltzmann constant is dimensionally. It is energy upon temperature, isn't it? The energy is force into displacement. So that's mr square T minus 2. And temperature is okay. You can use Kelvin K or you can use theta. I hope this is clear.
yes, sir.
Is Stephen's constant? So we know the relation dq by dt equals to So dq by a dt, the intensity equals to sigma t power 4.
Yes, sir.
So okay, let's find the intensity first. What is the intensity? Quickly. Energy upon time. So it's power. Energy upon time upon area. What is the answer? Can you see this?
Yes, sir.
Therefore, the dimension of Stephen constant is how much? Right?
Yes.
Surface tension. What is the definition? Force per unit length. So surface tension generally we write as gamma symbol in different contexts. So anyway, just write dimensionally mn square t minus 2 by L. What is the answer? mlt minus 2. Correct?
Yes.
Oh, my bad. Whatever I do. The force is mlt minus 2. So answer is ml0 p minus 2, right? Surface tension. Okay. What else? Density volume. Okay, that's easy. In the van der Waals equation, P plus what is the dimension of A? So when you add two quantities, then they must have same dimension.
Yes.
So to get the dimension of A, what you can say? Dimension of pressure must be same as dimension of n square A by, and pressure is force per area. ml p minus 2 by L square mole square. Volume is L cube. It is clear.
Yes.
So what is the dimension of A? Okay. What is the dimension of B? So you are subtracting the
L
term
cube by
NV. So NV dimension must be same as volume.
L cube.
Sorry, L cube. The dimension of B is how much? Okay. Okay, let's go to the next chapter. Rotational mix. Torque. What is the dimension of torque? Torque we have done. Moment of inertia. Angular impulse. Okay, that's okay. What is the dimension of theta? Angle. So if it is plane, it's radian. Okay, that's not required.
With dimensionless.
No, it's dimensionless. That's why. I mean, it's only unit. There is no dimension.
L by R. So
Yeah, it's dimensionless. Any ratio is dimensionless without, doubt. So all ratios are So when you write y equals to a sin omega t, so sine is defined for angle. So angle are dimensionless, dimensionless, dimensionless. So y will only go with a. So dimension of y will be same as. Understood?
Yes.
Okay. So okay, chapter. Let's go to which chapter? Gravitation done. What is the dimension of power? Energy upon time. Okay, what else? Let's go chapter. In current charge, electrostatic charge. So charge is current in time.
Yes, sir.
Dimension of charge is
Ampere T.
Yeah.
80. Okay, not recorded. You can just write. Okay. Voltage. So voltage or EMF or whatever potential, all will be equivalent of work done upon charge. Work done is electric field. The ES is A by Q. And this is same as different. Okay. Magnetic field. So what's your dimension? Always think of simple relation. F equals to ILB. I L. So always think about the simplest relation. Permittivity. So we have done this before. How much? Correct?
Yeah.
Permeability. So what is the dimension of mu naught? So which relation is easiest one to get the answer?
C square into epsilon naught.
Correct. But that's also you have to find epsilon naught, right? Something more is
So B is equals to mu naught pi by 2 pi r.
yeah, that's also. You can choose any formula. And B is ILB. I mean, sorry, F upon. So F equals to ILB. So you can compare this. Now compare these two. Because we have to only check the dimension, right? Minute by hour. Resistivity and resistance. So what is resistivity? So the easiest one is
Ohm meter.
the dimension of E. But the ohm itself is difficult, no? So field is easy. A by Q. And J is current upon area. So okay, 80. Current is area is, oh, that's confusion. Resistance,
Rho L by
ohm meter, right?
Yeah.
So it's rho into L by A. L by A is ohm upon meter. Correct?
yes, sir.
But there is something better, no? Ohm's law. So it is all about how fast you can think about the correct relation to get the answer as quick as possible. And then from resistance, you can get the resistivity, which is ohm meter, R, L. Correct?
Yes, sir.
So R into length, and which will become something mistake.
Yeah, the T power is nothing.
This is extra. This current only, no?
Oh yeah.
Now fine. R is correct. Yeah. So rho equals to R into L. Time constant is sum is always rho into epsilon. This is also sometimes useful. So you just need to know that the product of rho and E together will give you time actually. How? To derive this, you can think of a parallel plate catheter with say, medium with some resistivity also. And then if you convert into R and C, you get the answer. Isn't it? So,
Yes, sir.
what else? From electro, anything else? Dipole moment? E into L?
A. LTA.
Okay. So from modern physics, Rydberg constant? L inverse? Inverse lambda? Lambda is length.
Yes, sir.
Yes.
So these are something very basic, but one should know this. Self inductance. Energy. Oh, that's self L. So make it status. The speed of light formula is so sometimes they will ask you what the dimension of this. Okay, something special. Any other chapter left? Current density, we know. And if you know the rest, you can find the connectivity. Correct?
Yeah.
Conductivity. Again, this is better way of getting connectivity. You may find mobility, ionic mobility. That's the definition itself. Drift velocity upon electric field. You can, I hope you can do this from here. So what is the use of dimension? I mean, let's say that. Okay, dimension I haven't defined. Okay, anyway, I've written all dimension, but what is dimension? So it is the power raised to the fundamental units in order to express any physical quantity. So if you want to express something, so you can say the dimension here actually means the bare minimum content you have. So the fundamental units are like recipe. Okay, I'm sorry, like ingredient. So think in terms of the kitchen terminology. In kitchen, there is a very famous in every Indian kitchen. There is something called masala dabba, the masala box. And the same box create how many recipe? 1, 2, 3, or any number, right? So you can say the the world in which you live, the recipes are like the physical quantities, and the masala dabba is the basic ingredients, and then you add different proportion to create different taste, isn't it? So every recipe will not take the same amount. So as you change the recipe, what you change is the amount of different ingredients, isn't it? So this amount which you add in different proportion, that is called the power, which you raise. So power is like how many spoon or teaspoon of that ingredient you want to use in order to create the given physical quantity from the given ingredients. So in general, if nothing is said, it means you are supposed to use the basic 7 fundamental ingredient, which is called the which are called the fundamental units. So the fundamental units are your 7 different ingredients, and choose the proportion to express various quantities, as I have done all this. But if you go to a different country, and then once you go to a different country, then they change the masala dabba. So they have different combination. If you go to most of the Southeast Asian country, they use excessively garlic, lemongrass, of course ginger, and they mostly eat the boiled food. And the amount of the use of spices in the powder form is very less, as we do. So we use a lot of powder form ingredients. They use a lot of, you can say, the crushed ingredients. So they use a different proportion of different things. So you can say every country will have a different masala dabba. So by default, our masala dabba is the fundamental quantities. But when you are solving the question of JEE-Mains or advanced, and if they mention that, okay, choose these as the fundamental units, express this quantity in terms of these. So those questions will also come into picture. So your masala dabba is the dimension of all recipe. Okay, so dimension is this is the given set of ingredients. So the type of ingredient which is confined in the dabba is the dimension, and using those dimensions you take in different proportion and you create the given recipe. So the recipe may be any physical quantities. Oh, we forgot the capacitance. Capacitance. See, what is the dimension? Tell me. Which formula is best?
Q. Q is equal to C.
Two questions, CV. 80. Correct?
Yes.
ML square T minus 2. 80, right?
Yeah.
How much? It's very badly written. Okay. Okay. So using the standard masala dabba, we have created all this thing. Whatever you comes to your mind, just let me know. I'll put the dimension there. So now we are going to use some concept. So use of so you know the formula S equals to
UT plus half AT square.
so what you are trying to express S, right? S is what? Displacement. So dimensional correctness means what you are writing on the left and what you are writing on the right, they must be dimensionally same. And what we add is we only add the so addition or subtraction of similar dimension is only possible. Can we add mango with oranges? So 3 orange plus 2 apple, how much?
3 orange plus 2 apple.
So it means you cannot merge into one, right?
Yes.
So the rule of addition is what is the rule of addition? The added terms must be dimensionally compatible. So the terms which we add or subtract to each other must be dimensionally compatible. Then only we can add or subtract. So dimensionally, the UT must represent the dimension, dispersion, and half this will also represent dimensional displacement. But a physical correctness, the dimensional correctness cannot be the physical correctness all the time. So if I write S equals to UT plus AT square for constant accession, is the formula dimensionally correct?
Yeah.
But is it physically correct?
No.
So dimensional correctness cannot guarantee physical correctness. Okay, so this is not the ultimate test, but at least you can ascertain that if something is dimensionally incorrect, then it is 100% physically incorrect. Correct? So dimensional correctness cannot guarantee physical correctness, but vice versa is what? If something is dimensionally incorrect, then it must be physically incorrect, right? So whenever you add something, you have to take care of this. So if I write V equals to A plus BT square plus CT cube, what is the dimension of A?
ML minus.
A is
LT minus.
its velocity, no?
I
What is
took
the dimension of B?
meters by mistake.
Dimension B is T is time, of course.
LT.
Huh?
L t power minus 3.
L T per minus 3. What is the dimension of C?
L t power
LT
minus 4.
Correct. So this is the one use of dimensional. So when you, okay, when terms are multiplied, then do we need to check the dimensional compatibility?
No.
No. So in multiplication division, we don't check the dimensional. Okay, what about the exponential? E power something must be?
The power must be dimensionless.
Any power must be dimensional. So when I'm writing something here, let's see if I'm writing AT. So what is the dimension of A?
T inverse.
If I write F equals to C e power minus PR square. So what is the dimension of C?
Same as that of F.
And what is the dimension of K?
1 by r square.
M raised to minus 2. L raised to minus 2.
Correct? L minus 2.
Yeah.
Okay. So you will get the, okay, any angle is dimensionless and any sine cos tan is always dimensionless. So if I write y equals to or something, so here every term which you are adding or subtracting, they all must be dimensionless individually, right? So what is the dimension of K here? And dimension of omega here?
T
Because each term must be dimensionless, because dimensionless minus dimensionless is also dimensionless. And the dimension of sine will be dimension of C, right?
Yes.
Okay, so so for dimensional correctness, we use the dimensional analysis. Use number 2 is what? Unit conversion. So 1 meter is how much? Centimeter?
100.
Okay. So 1 meter is, say, I mean, 100 centimeter. Well, 1 kg is how much gram?
1000.
So let's say if you want to write a 1 Newton in CGS. So you want to convert SI into CGS. So now you're going to take a smaller value, because centimeter gram second is a different unit in which things are really small. 1 centimeter is very small compared to the 1 kg, right? So when you try to measure the same quantity with a smaller unit, the corresponding number will increase, yes or no? But what remains constant? The number used into unit used, the product of the two remains. So as you decrease the size of unit, the number corresponding will grow. So let's say you're trying to measure this length. If you bring a meter scale to measure this rod, the number you will get is less or more compared to if you use the centimeter scale. Like if you want to express it in centimeter.
Less.
Less number, sir.
So meter will have less number and centimeter will have more number.
Yes.
Yes, sir.
But the number into unit must be constant, no? Because the what you are measuring is n into u. So that is constant, isn't it?
Yes, sir.
So you want to measure 1 Newton as what in CGS? So what is, I want to know N2 actually, what you pick. So how to get this? So what we do is we write the dimension on both sides. How? So let's write down. Write N1. And what is the unit of force? M
kg meter
L
per second.
T minus 2.
So you can first write like this. Okay. And then dimension they are same. So n is number, so dimension they cannot change. But now substitute the dimension, I mean the each term with the corresponding unit. So in SI, what we write? N1. Mass we write as kg,
kg,
length meter, time second, mass gram,
Grams.
centimeter. Okay. Now convert into similar units so that we can cancel things. Kg we can write as 1000 gram, meter is 100, centimeter. Bring the number outside because we are multiplying here. So what do we add? N1 10 power 5. So what you can get the answer? N2 is. So if N1 equals to 1, N2 equals to. You realize this?
yeah,
Yes, sir.
Yes, sir.
That's why we say 1 Newton is how much? 10 power 5
9,
dgs, which is called dyne actually. Okay. So if you want to convert 2 units from one form to other form, so you have to find the factor. What is the new factor? So express the first right in terms of dimension, then substitute the value of dimension, and whatever they are saying, substitute there, you get the new answer. So this formula is useful to convert the unit. So for unit conversion, we again use the dimensional analysis. So 1 joule is how much earth?
10
The
raised power 7.
10 raised power 7. Very good. So 1 joule is, and we can prove it in the same fashion. But not only that. Okay, if I give you a different unit, okay, in which the mass we measure in 10 gram, that's like fundamental, and okay, the length has 25 centimeter, time is 0.1 second, and these are fundamental. And now what will be the conversion of 1 Newton into, this is called which unit? Let's name it. This is, I mean, this system unit. Let's try to name it. Okay. Let's call CKP system random. And now I would like to convert 1 Newton into this system. So we have to use the same relation. Of course, N1 U1 equals to N2 U2. And we have to put the dimension. Okay. So in the SI, what we write? kg, meter, N2 I'm trying to put, but M here is how much? 10 gram. L is sorry. How much? Tell me. Do you realize this? And kg we can write as 1000 gram meter. So I'm trying to express in a similar term. So 10 into 25 into -2. So now the answer is different, right? Do you realize it's a different answer?
Yeah.
250 by 100, which is so 1 Newton is 4 into
Sir?
10 power 5. Yes.
Sir, it will be 10 power plus 2 in the first column last equation, right, sir?
This is 10 power minus 1, no?
So, but then 10 power, 0.1 second, the entire thing will be in the denominator.
So 0.1, I'm writing 10 power minus 1 power 1. Oh, yeah, correct. It's minus 2, no?
Yes, sir.
Yeah, so it's plus 2. My bad. Very good. So now, yeah, that's why the answer was not meaningful. So N2 into how much? 25 into 10 power 3. So it is N2 is how much? Only 4, right? So 1 Newton is 4 CKP. And that should be the logical answer because we are growing the value of size of unit, right? So my mass is 10 gram as fundamental. My length is 25 as fundamental. It's not, and time is 0.1. Are you getting how to write the answer in different unit system?
Yes, sir.
So whenever you have the the self-defined value, substitute and get the answer. Okay. So this kind of question is also very common. The application of N1, N1, N2, N2 is very typical. Sometimes they change the complete ingredient. There was one question, if I remember. Okay, we'll come to that. What is the third application? So in every research, to establish the fundamental relationship between variables, we always use the dimensional analysis to get the first idea that what is the proportional or empirical relation. So that's called the principle of homogeneity. And it simply says that any physical relation must be dimensionally equivalent. What I have said already, any physical relation so in this, there are some famous which you should know. Quantum, length, mass, time. Let's say you are trying to do the research. You realize something that in nature, the G, H, C are very fundamental. So you go to the, a cosmic kitchen. So it is in the NASA, let's say, so or is the ISRO. So we have the cosmic kitchen. And in that cosmic kitchen, we have only 3 ingredients, G, H, C. And these are the fundamental ingredients. Now you're supposed to create the dimension of length. So I say this as quantum length. Now I would like to know what is the quantum length proportional relation in terms of G, H, and C. So it is like I'm telling you that can you prepare a recipe or this prepare this dish using the ingredients G, H, C. Now you're confused about the proportional use, like how to use the different proportion. And you have no idea. So let's say the dimension of length is proportional to the A teaspoon of G, B teaspoon of H, and C teaspoon of C. What is C here?
Speed of light.
H is,
Planck's constant.
and G is,
Universal gravitational constant.
okay, whatever. Now, to create this recipe, you are going to use what? GHC, correct? And using the GHC, you are going to prepare this recipe, but you're not aware of the right proportion. So how to assume the proportion? That's called dimension. You choose some power. So A teaspoon G, B teaspoon H, and C teaspoon C will create the recipe length. So as per the principle of homogeneity, the relation must be dimensionally equivalent. The dimension of QL must be same as. So do you realize this first part?
Yeah.
And we know the dimension of any length, whether it's quantum or any length, is L. And G we have derived it. So if you don't know, quickly derive the G value, put it here. So everyone derive and tell me answer. Don't see, just derive and tell me the answer. Okay, what is G? Can you derive and tell me the G dimension quickly? Hello guys.
Sir, m power minus 1 L cube T power minus 2.
Okay. Power A. Planck's constant H is how much? You know this answer. E equals to H nu, so it's ET. mn square T minus 1, right? Tell me guys, is this correct?
Yeah.
And the speed of light? So the next step is rearrange in terms of power of A, just like equal solving equation. M power minus A plus B, right? L power 3A 2B C and T power minus 2A minus B minus C. Right? Do you realize this equation the way I've written?
Yes, sir.
Compare with the left hand side. So what is the power of M? 0. If you compare minus A plus B is 0. It means A equals to B. What else? 3A plus 2B plus C equals to 1. Correct? And minus 2A minus B minus C equals to again 0. But A equals to B, so you can write here.
Minus 3.
So it is 3A equals to minus C. Correct? Tell me guys, is this correct? 3 equals to minus C.
Yeah, so B equal to half.
So C by 3 and B is same, right? Now because we know everything in terms of C, so we can write as 3A is how much? Minus C by 3. B is A, which is again minus C by 3. So what are you getting? Minus C. C turns out to how much? Minus 3 by 2, right? So A equals to B equals to how much? Plus 1 by 2, correct? So the quantum length is proportional to G power how much? A. H power and C power. So it seems like something really nice. And now this today we call this length as the smallest possible measurable length. We cannot measure less than this theoretically.
It should be C cube na, in the denominator.
Yeah. Correct. This is C cube. So quantum length is how much? GH by C cube. Similarly, can you find the quantum quantum mass.
Yes.
So on the LHS, the L will be replaced by M, capital M. So please find the quantum mass and quantum time. Everyone,
Okay. Sir.
do it first.
Sir,
Yes, still.
sir, A is equal to -1/2, B is equal to C is equal to 1/2 for quantum mass, sir.
Okay. Just a moment. So you're getting it how much? G power 1/2
Sir, -1/2, sir.
and H
1/2, sir.
and C.
C also 1/2, sir.
So the answer is it means CH by G under root, right?
Yes, sir.
Please confirm, guys. Are you getting the same answer? Done.
One second. Yes, sir. I'm getting the same.
Yes, sir. Getting similar answer.
Very good. Okay, so let's do this question. So Ishmael, you can find quantum time.
Yeah.
So meanwhile, you solve this question. I'll give you the next question.
Sir?
Yeah.
Sir, for quantum time, I'm getting an answer.
Yeah. Tell me.
Sir, I'm getting A is equal to B is equal to minus 1 by 2
A equals
and
to B
C is
equals to-
equal.
The quantum mass
Ma-
is coming GHC by G, correct? Yeah, this is correct. Quantum time is
Okay.
quite different.
So I'm getting A equal to B equal to half.
G and H equals to half, which is correct, and C equals to
Just a sec.
Sir, A is equal to B is equal to minus half, I'm getting.
Something is missing.
C is equal to
Reject
minus 5 by
minus 5 is the right answer.
Yeah.
Just calculation, just check the calculation.
Okay, sir.
Okay, so the next question is, hopefully this should come in the exam. I'll type it first. So the resistance R to the motion of a ship depends on the velocity of ship L, the length of ship, rho, the density of ship, sorry, density of sea water, and G, the acceleration due to the gravity. Find dimension of R. So what is the dimension of R? This is right answer. Are you getting the answer, guys? Tell me.
Yeah, sir.
Yes.
Got the same for
Yes,
quantum.
sir.
Very good. And this is so famous that every year, if you see, I mean, in the last 2-3 years, sometimes they will ask you quantum length, sometimes quantum mass, sometimes quantum time. So these 3 questions are very typical. They keep on repeating throughout the decade. And they have no option. I think this is the only question they have. Anyway, done. So one more question, which is very famous in JEE domain. This was the first dimensional question in 1981 in IIT-JEE advanced. It was subjective. So a gas bubble So you have to suppose to solve this question also. And the last question which I'll give you. Okay, first we will copy this. Can you click the photo? I'll go to the next page. Just two more questions, then we're done almost. Two, three questions. Okay, can I go to the next page?
Yes.
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 Okay, another one. These two questions are done. So the resistance of motion depends on velocity v. So r proportional to va. So what is the resistance meaning here? Any guess? Tell me guys, what is the resistance here?
Sir, the same as we learned in current chapter.
No. This is like
Force.
Decelerated.
a force. Here resistance
Oh,
means the resistive force actually.
okay, sir.
Or you can say drag force.
Yes, sir.
So now there are four variables. It depends on velocity, length, density, and acceleration due to gravity. So is it difficult or easy? Can you find? Density is what? Now compare. I don't think it's difficult to solve. All those four variables. But if we have 3 question in 4 variable. Let's see. So B is 1, which is known to us. And B is 1, so A plus C plus D is 4. A plus 2D is okay. Technically, it should not be more than 3 variables, but if it is 4th variable, density, volume, A plus C plus D equals to 4, A plus 2 equals to 2. Okay, so A plus D is 2 minus 3. C minus D equals 2. No, still it's impossible to solve.
But you can just make one of them 0, right? Because we just need 3 equation 3 unknown, so we can just make one of them 0. Shouldn't be a
Yeah.
problem.
Actually, I think the accessibility to gravity should not be there. That's my feeling. If I make the D equals to 0, what will get the answer for ABC? Just make D 0. I think this is something extra.
Sir, so that method is like going by the options.
No, there is no option. But the G, I mean,
Sir,
see, we
no,
cannot
sir,
have.
like if G, yes, sir.
Tell me.
Sir, so like if G is not there in the options, then we can automatically eliminate it, sort of.
Correct. I mean, it is from the subjective book actually. It's very old question. I'm using book which is 40 years old.
Okay, sir.
Because they will pick up the question from the old question, right? Now what we can see here,
Yes.
M power B, L power how much? A minus 3B plus C, and P power minus A. That's it, right? So A becomes how much? 2. B becomes 1.
Is
A
to
minus 3B plus C equals to 1. A is 2. B is 1. So C is how much? 2.
2.
So the R turns out to be proportional to V power rho L square. Hmm. Okay, solve the next question. That's the JEE question. This is some other question. JEE subjective long term. It's an easy question. You got the answer for this question? So for second, what is the answer for ABC?
Sir,
Yeah,
I think B is half.
B is
C,
half is correct.
C is 1/3. And
Correct.
A is minus 5/6.
That's correct. All are correct.
Okay.
Very good.
Sir, the next page.
Yeah. You got the answer this part?
Yes, sir.
Okay. This question. What is coming the T relation? T with
So
the rest
under root rho r cube by s.
Q by
S.
okay. Surface tension, right?
Yeah.
That's the right answer. Here. In JEE-Mains, imagine you get a question and you feel that okay, sir has not taught. Quite possible. So I haven't discussed, I haven't taught, but the question is there. It is very difficult question. The moment you feel so, think about dimensional analysis. Because any weird question can be solved easily with the dimensional analysis. And that's why you are not supposed to taught that concept. Then the rest two?
The second one is just rho C lambda.
Yeah. Correct. Rho C lambda, correct? This is what you said?
Rho into C into lambda.
No, that's the right answer. So are you all getting the answer? Tell me, guys.
Yes, sir.
So what is the answer for the last question?
Sir?
Yeah.
Sir, I'm getting okay. 1 second, sir. I'll just convert it into the units.
We are asking for the last question.
Sir, yes, sir. Sir, viscosity to the power 1/3.
You mean to say 8 upon 1/3?
Yes, sir.
That's it.
Sir, no, sir. Then density to the power -1/3 and d to the power -2/3, sir.
Okay. Into. Let's
Sir,
see.
yes, sir. Into, sir.
I think 3 is coming extra. I mean, it is 1, 2 minus 1, something like this.
Okay, sir. I'll check, sir.
Yeah, just check this. Okay, I think in this question,
So
yeah, tell me.
1 minus 1 minus 2. And
Yeah, once again,
uh,
eta.
eta by rho d square.
Yeah, that's correct. Very good. I think viscosity we have okay, I haven't given the relation viscosity dimension. Oh, I have missed. So what is the
F by
dimension of
R.
viscosity? I think m
M L raised to -1 T raised to -1.
And to find the dimension of viscosity, you can use the relation. Viscous force of Stokes law 6 pi.
Stokes
6 pi r eta r.
So 6 pi is constant. So dimension of 8 I can get from here. And you have to supposed to use that relation. Okay, I should have given anyway. Okay, so if you do so, you will get the answer. I hope so. Done. Okay, what I'm thinking is that this question is that we saw. Yeah, this question. Here the resistance, I think they have taken the resistance per unit length of shape, or maybe what I'm believing is the resistance, it is again like a the viscous drag from here. I'm getting the idea. Okay, let me tell you. The resistance is proportional to velocity gradient. You know what is the velocity gradient?
Yes, sir.
V by L. And then, okay, it is actually velocity gradient. But the L is here length of shape, but here L is the depth actually. So I cannot use this also. Or maybe I think resistance is the force per unit length of shape. I mean, they should have mentioned, but I'm just guessing all this. So resistance is like a force acting per unit length of shape. That's why the length should not be taken into consideration. Then we can take the rho V and G per C. If you take these three, let's see how much we're getting. Just I'm making a guess here. I don't do this. This is not required. So density is what? Mass so this is force upon length. If I choose this way of writing, let's see what we got. 3 and if you compare A equals to 1 and minus 3A plus 0 and minus B minus 2C equals to minus 2. And if I put A here 1, so minus 3. So B plus C is 3. So B plus C plus C. So 3 plus C. 2. C equals to 1. And C equals to 1 means B equals to 2, right? So we're getting A equals to B equals to G. Rho V square G. And okay, anyway, this could be the answer. Okay, not required. Okay, now I have like the last question. Do I have a space here? Thank you. Have saved the space here. So do I need to solve any question? Any of these? Tell me. So in the chapter of fluid, I mean, of course, viscosity only, there is something called the Poiseuille equation, right? So if you have studied the viscosity, I have derived it from the very basic. Now JEE says that this is not part of JEE syllabus, but nevertheless it asks because it is based on dimensional analysis. So indirectly, JEE has all the right to ask. So this equation is for the flow of viscous liquid through a tube, if you remember.
Yes, sir.
Anyone who remember this?
Yes, sir.
Okay. So it says that for the flow of liquid through a tube of radius r, length L, and the pressure difference. So we have a pressure here P1. So pressure is P1 and P2. The radius is R. And the viscosity is eta. So it says that the volume flow rate what is volume flow rate? D volume by dt, also known as what else we call discharge rate. So it is proportional to pressure gradient, and not exactly we know, so let's call power A. Then viscosity, power B, and the radius of the tube, power C. So if I represent the P as pressure difference, I'm taking P as a variable. It is P1 minus P2. Let's say the flow is towards right. So P1 is more than P2, let's assume. But take P as a variable, L as variable, R is variable. Can you derive the, and eta of course. Can you derive the volume flow rate relation? What is, we simply write Q actually. So what is Q proportional? It is P by L power A, eta power B, and R power. See, can you tell me ABC value here? Quickly,
Yes.
please tell me. So actually, this is based on the dimensional analysis. That's why I mean, one should be aware of this. And similarly, we also derive the Stokes law from the dimensional analysis, if you remember.
Yes, sir.
If you have watched the lecture, you know this. Done?
Yes, sir.
Okay.
Sir,
What is
I
the
got
relation?
A.
Yeah, you got A.
A is equals to 1, B is equals to 1, and C is equals to 4.
A equals
Sorry,
to 1,
B is equals to minus 1. B is equals to
B
minus
equals to -1, and C equals to
4.
Oh, very good. Are you guys getting the same answer? Tell me. Hello, hello. So this Q is the volume flow rate, discharge rate, and it is coming P by P. Like this, no? P upper 4 by L, right? Hello guys, tell me yes or no.
Yes, sir.
Okay, so if this is the answer, then the volume flow rate is some constant into V upper 4 by eta L. And this constant will later on study. I mean, if you have seen the actual derivation, it's pi by 8. So generally, you will see in books it is written like delta P by R power 4 Okay. Now, this we can always compare with the electrical analogy. Although I have taught this, but it is again an opportunity to revisit. So if we talk about the resistor, then the potential difference is the cause behind the current flow, right?
Yes, sir.
So current is the charge flow rate, which we write as a potential difference upon resistance. So every viscous fluid passing through a tube, the voltage will be replaced by the pressure
Difference in pressure.
And we have to define something called fluid resistance, RF. If you write the relation, this relation in a fashion like this, del P by 8 eta L by R power 4. You can see this is like a current. Q is the flow rate, so it's a current actually. It is not charge. So if you compare, this is like delta P by R fluid, isn't it? Hello guys, tell me.
Yes, sir.
So what is the fluid resistance of a tube? You can see that as L will grow, the fluid resistance will also increase proportionally. So the resistance of fluid is proportional to L and inversely proportional to fourth power of the radius of cross section. That's why the viscous effect is very much prominent in a narrow tubes. So if R is very close, let's say if you talk about the capillary, the resistance of the fluid is very high. It's as the thinner the tube, the R becomes tremendous, and that is why when the blood is flowing through the veins and arteries, the cross-sectional radius matter. Okay.
Yes, sir.
So as the narrow, it will become narrow down. So normally what we can think is that as the arteries will not block, the blood flow will become very fast. But that's not the case. As the artery will shrink, the viscous will grow and it will also reduce the blood flow. And if the blood will not reach the different parts of the body, then it will create a stroke. Okay, so this relation is actually used in the mostly pathology. They use the viscosity of the blood sample, and they also determine the radius of the arteries to understand that is the fluid resistance is good or bad or whatever. Okay. Anyway, so everything is studied, and of course, viscosity is one of the factors. So the nature of blood, how thick the blood is, how thin the blood is. So all depends. And like neither too very, high flow rate is also not desirable because the heart will pump the blood at certain rate and so on. Okay. So I hope the dimensional analysis is over, and you can derive one more formula, which is Stokes law. So you all remember the Stokes law? Let me drive this
Yes, sir.
quickly. So Stokes law talks about the flow of a spherical body like dust particle, raindrops through a viscous medium. So generally in lab, we perform using the glycerine actually. And in the glycerine tube, we drop the steel ball. You can see this steel ball will fall through this viscous liquid, and the coefficient of viscosity is eta. The radius of this wall is r. The density of liquid is rho. The radius is there. Now, what Stokes realized that the viscous drag due to the given medium is proportional to eta power a, r power b, and v power c. So the viscosity offered by the liquid or the gas also. And this law is only true for the tiny objects, basically dust particle, maybe the RBC, WBC in the blood sample. So within the blood, we have a large number of particles actually, which kind of propagates through the blood stream, and they do face the viscosity. Okay. So the microbacteria, I mean, at what rate they can swim across the blood in the frame of blood itself. So there, the viscosity, this formula is very useful. In real life, when we are driving the truck or whatever, so the viscosity is very complex. So viscosity depends on the shape of the object, definitely. So a giant Hummer car is not good in terms of drag force, but it's so powerful that it can wade through the high viscous, I mean, air drag easily. But generally, we try to, when we design the bullet train, we try to streamline the flow process to decrease the drag as much as possible. Okay. Anyway, so in you can say for the tiny objects like the micro dimension objects, milli-dimensional objects, dust particles, iron, you can say gaseous ions. In the Millikan Waldorf experiment, what you perform is again the Stokes law. So there, this is, I mean, this viscosity really matters. So when they pass through the medium, they do face the resistive force, which we call viscous drag. And if you try to use the dimensional analysis, I hope you remember the ABC value.
Yes, sir.
So all will come.
One.
So this is eta RV. You put the constant K eta RV, and now K from experiment is found to be 6 pi. So when this steel ball will fall through this viscous medium, then again it will experience the gravity, the buoyancy, and the drag force, the viscous drag. So buoyancy is due to the volume displacement. And then for terminal velocity, you balance the force, correct? So in a way, this is the chapter called Stokes law. So for terminal velocity, what you write here? All forces are balanced. So let's say it is moving with some velocity Vt as terminal velocity. So bond force is V rho g, which you can write as let's say density here is rho. So bond force right is m rho mg rho by d. Mg rho by d. 6 pi eta r v terminal mg. 6 pi eta r v terminal is mg common 1 minus rho by sigma. Sigma is the density of the steel ball or the dust particle or the liquid drop. And then mass we can write as so mass upon density is called volume of the steel ball. So this is 4 by 3 pi. So this is the and derivation of the terminal velocity, because we will get question based on this, which is 2 by 9, right?
Yes, sir.
Gr square sigma minus rho by eta, right?
Yes, sir.
So they'll ask you the various comparison question that for this ball, this liquid, this is the terminal. If I change the liquid of double viscosity, double radius of the ball, And if I take it to the moon where G is G by 6, okay. What is the answer? I mean, you understood what I'm going to ask. Right? So again, these all are questions from different chapter, but somewhere they have the relation with dimensional analysis. So knowing the dimension is a really powerful thing. I mean, it will help you in understanding other things as well. So after dimension, we can go to the errors, right? Okay. So what is error? So error means here actually error of measurement. It's not your mistake something. So error is called as a error of so measurement is an experimental process in which you use some device, right? So you have some device which you use for various processes. So the device, the instrument will have some limitation. And because of that limitation, of course, you incur some error. I mean, you incur some inaccuracy, which is unavoidable. I mean, inevitable, you can say. You cannot stop it because the way we have designed the instrument, it always comes with some limitation. For example, if you're using the meter scale, can you measure anything below 1 millimeter in the meter scale? Because the way you have, drawn the calibration, the marking, you can see, the calibration will have some gap, and that gap is roughly equivalent of 1 millimeter, isn't it? So if anything falls in that 1 millimeter, can we measure it? Hello guys, tell me.
No, sir.
So the definition of error is simple. There are many definitions. In different contexts, it will be different. But here it is maximum deviation, possible deviation from the true value. So what is error? Maximum another question is what is true value? How we know what is true? How to know the truth is statistically. To know the truth is statistically, we have to repeat the experiment. So it's called repeated trials. For example, if you want to go to a destination, so you come out of your home and you ask some stranger, where is this particular station you want to go? And from your home, there are two ways, either left or right. So he says, I think it's left. But you're not sure. So what you do is you ask the next guy and he says, I think it is right. Now you're double confused because the statistical answer is 50-50. But you want to reduce this probability and you want to get bias. So you ask the third guy, he says left. Then you ask the next guy, he says right. Again, you're confused. It's 2:2, again 50-50. So what you do, you keep on repeating this experiment for almost 1 year. And that's a really bad way of going to station. Okay. But somehow our society is already biased towards this right answer. So if you ask the auto wala, because he wants to earn money and he is well aware of the routes and paths, he will take you there. So statistically, the chance of error is very less if you take the guy who is well traversing all the routes all the time. But when we talk about the, statistically, we are very unbiased. We try to derive through the repeated trials of the same experiment. So we repeat the experiment again and again, and we get some value. So we get something more than the truth of the true value. Sometimes we get less, more, less, more, less, more. And then once you repeat this experiment infinite times, you have now confidence. Okay, you have confidence that, okay, I think now from my statistical measurement of the same experiment in the repeated fashion, I must converge somewhere towards the reality, the truth. So to get the truth, what you do? You take the average or the mean value. So mean value is a way to kind of chase the truth or achieve the true value. Because if you do not know about the truth or the true value of any experiment, let's say now today you know the value of G is 9.81. But what about Newton? Was he knowing the value? And was he determining the value in the repeated trials? What he did? Was he comparing against something standard, or was he trying to derive through experiment for the first time? So he must be doing the statistical way. Okay. But luckily he was working under the great astronomers of that era. So there was a very rich guy called Tycho Brahe, and he had his own observatory. And he has an assistant called Johannes Kepler. Then Kepler was a very, you can say, a guy with a good observation skill. So he kept on observing the position of different stars, and he made a kind of cheat sheet, or you can say, in a way, he kept on dotting down all those observation in numbers. He did that thing for the entire lifetime. Okay, so Tycho Brahe established the lab, this observatory, and then Kepler was working there under his supervision for a very long time. And he was very much into this, you can say, astronomy, okay, and geometry actually, the Tycho Brahe. He was actually a king, son of a king, so he could have running the country and all, but he chose to be part of the cosmology, or you can say astrophysics. So with his great passion, he went on this domain and established the observatory across Europe, in fact. So that was a very kind of a renaissance for the astronomical, changes which happened across the world in that time. So he went to different places to design the telescope and so many other things. And because he was rich enough, so he can go anywhere, he can buy anything he wants. No one can, of course, oppose him or refuse to give whatever. Anyway, but that changed the course of history in a long way. So Tycho Brahe, assistant Kepler collected the data over that lifetime. Then came the Newton. Okay, so he got to again got to work with the Kepler in his again the same observatory which Tycho Brahe established long time back. And then he saw the data, and from the data itself he established the fact what we call today the Newton's law of gravitation. Okay, so he realized the data is having the inverse square relation, and that's a big a revelation actually. So nature had this relation, but the data gave you the first mathematical glimpse into. So that's why the Newton is actually a mathematician. So he was more into mathematics, and he was able to figure out the nature through the mathematics. So he was a very good mathematician, very good statistical observer. Also, he designed the experiment also. So you can imagine that he is really a big genius. Okay, and then from the data he realized what is the truth. Okay. Truth is the hidden thing in nature, and experiment is the way to reveal it. Okay, so when you do the experiment repeatedly again and again and again and again, even with the not so accurate instrument, you always approach, because your answer always oscillate to and fro with respect to the truth value. So the average is like trying to go towards the point of convergence of any experiment. So it is believed that statistically a large number of trials will lead to more accurate convergence. Okay, that's why the repeated trials are the way to perform experiment. Even in school, it is written in the practical notebook. If you get a 3 concurrent reading, then your experiment is done. Okay, successful. So it's called the Concord rating, right? What do you say? Concord rating, right? So 3 readings which are very close to each other. So the truth is, I mean, simply you have the mean value actually. The mean is way to reveal the truth in any experiment. So every experiment is started with the trials. So we have, let's say, some name experiment or number 1. It could be anything. It could be, let's say, you want to determine the access unit to gravity using the simple pendulum, relation, or you want to find something other. Maybe. But every experiment will begin with, okay, you have some name of the experiment, experiment 1, let's say, and then you start the trials. So you write here the serial number, and then you write the first trial, the second trial, the third trial, and dot dot dot, the nth trial. Okay. And in the first trial, you get some value, right? So what you are measuring is, let's say the physical quantity being measured is, let's call A. A is the name of physical quantity being measured. So we'll talk about the instrument later on, but let's say you're trying to measure the physical quantity. But when you perform the first trial, the answer you get is A1. But in the second trial, you get is A2, A3. And then eventually what you get? You get AN, okay? So far, so good. So this is the repeated trials. So what is the true value? What is the truth here? So true value is actually called mean value. And statistically, the mean is the truth. If you don't say me the truth, I'll find the mean. So what is the mean value here? A1 plus A2 plus dot 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 AN upon capital N. Okay. So once you get the truth, the next step is deviation. And what is deviation, guys? How far you got the observation from your true value, the truth. So the first deviation we can write is A1 minus AM. What is AM? The truth. What was your actual value? A1. So what was the deviation? A1 minus AM. So this will give you the range of deviation, like how far your answer went from the reality. The next, what you can write here? A2 minus AM. You may name it del 1, del 2. And then you got, and then you got AN minus A mean. But the problem with the deviation is it could be positive or it could be negative, isn't it? So if you try to find the mean deviation, it could give you 0 answer, right? So if you add something positive, something negative, the mean deviation is something which is a very wrong, you can say, representation of the error. Because error doesn't mean positive, negative. Error means how far you went, either less or more from the reality. What is the extent of deviation? I would like to know the extent of deviation. So what do we do? Instead of deviation, we find the absolute deviation, the modulus value. And so we define something called mean absolute deviation. How to find the mean absolute deviation? And how we represent it? So the symbol is delta AM. And we represent it as mod of every term. Because we are only interested in what? We are interested in the deviation, not the reality. I mean, not the sign actually. So once you take the mod, you make sure that every term is positive, and then you check the average of this positive. This is called the average of deviation. The answer is oscillating to and fro about the mean. Then you're trying to find the average of the oscillation. And what you get here, the mean absolute deviation in physics we call this as error. So now error is nothing but a mean absolute deviation. So I hope the experiment is clear, how the experiment is performed. What is the truth value?
Yes.
Okay. So statistically, the error you can also write as delta m, which is called deviation. But you will study, I mean, in mathematics, there's something called variance, right? Have you heard the variance?
Yes, sir.
So when you do the variance, you square the each term, right? AI minus A mean. How we write? Actually, we write like this: the trial value minus mean value whole square summation upon number of trials. Do you remember this?
Yes.
Okay.
Sir.
And but the thing is, when you find the variance, you square the number. So to get back to the same dimension, because dimension it's wrong, right? I mean, no, this is not the dimension of error or deviation. It is square of deviation, isn't it? So how to get back the, I mean, deviation again?
Under.
You take the under root. And so you name it standard deviation, isn't it? If you remember. Again, sometime you will see the formula will have n minus 1, sometime it is n. So we have the sample, sample is standard deviation, and then we have population is standard deviation. So we use sample n minus 1 and population n. Why we use this? Again, it's a big theory. It's called degree of freedom. Oh, yeah, there's a concept of degree of freedom there also. In statistics, they use the idea of degree of freedom. So this is called standard deviation. How to find? Find the mean value first separately, and then subtract the mean value from each term, square it, add it, and take the average. That's called variance. So this is called population pop variance. This is pop standard deviation. For sample, what we do? Understood? For sample, we subtract 1. Okay. And why we subtract 1? So population is the entire inverse and sample is a part of it. So when you take the sample out of inverse, you decrease its degree of freedom by 1. That's why n becomes n minus 1. It means you bring certain certainty. I mean, this is the biased relation. So once you have taken some sample out of the inverse, it is out of the population, it is kind of biased by 1 degree. So that's why we put n minus 1. Okay. So the n minus 1 is a big thing. I mean, I understood this n minus 1 by watching roughly 300 to 400 hours of video lecture by the greatest mathematician. And he said at one of the lecture in just tiny second, like in 3 to 4 seconds of lecture, he said that simple term why n minus 1 is used, because 99% teachers doesn't know what is n minus 1. Anyway, it's a degree of freedom actually. But this is not required for our chapter. What I have given you, because you are also studying the mathematics, you can use there the standard deviation and variance, and you will be, okay, why we use variance. I have explained in some lecture, I don't know here, but the variance is actually used for optimization of error, or you can say minimization. So if you know mathematics, the modulus function is non-differential function, right?
Yes, sir.
And that's why the modulus function, this mean absolute deviation, is a function. If you think this is a function, so it cannot be differentiated. That's why the error or the deviation, mean absolute deviation is not the good way to optimize or minimize the error in some statistical way. So we use variance, which because variance is a square function which can be differentiated easily, and that is the actual purpose behind the the use of variance. So we were good with the delta am actually, but later on we when we realized that the delta am cannot be optimized for any reason. So the only way is use the new definition called variance. See, there is a history behind every definition, why we define something as we proceed. And why we define the standard deviation? Because by squaring the function, you disturb the dimension. So to get back to the same dimension, what is the rule? Take the root. Understood? So these all are like connected. Why we are doing all this? Anyway. So how we express the measurement? So to express measurement, the physical quantity we write by the name A, and it will have the true value, which we write by AM. Then we use a plus minus sign to just convey the message that there is a deviation, there is an oscillation of the answer around this mean value by this magnitude. So the term on the right and left of plus minus both are positive. I mean, it could be negative also, but the term on the right is always positive. So this answer is always positive. This could be plus minus as per the sign of the nature of fundamental quantity or physical quantity actually. So this is how we express the measurement. So how to express the measurement? The name of the quantity, the true value. So every measurement is what? True value plus minus error. And that is why the true value we replace by the mean value, because statistically this is how we find the true value, and the error we write on the right hand side. Error is not some mistake. Error is like in every experiment you're bound to get it. Okay. An error is called the uncertainty in the measurement, that which is a better way of saying it. So the error will have the next definition. Uncertainty. You're not certain about certain, I mean, some value of measurement. Uncertainty in measurement. So either you can say maximum possible deviation from the true value, or you can say uncertainty in the measurement. So in context of instrument, we call uncertainty in measurement. In context of statistical definition, we say the maximum possible deviation. So these are two definitions in two different contexts you can understand. For example, if I have a scale with some calibration, predefined calibration, I'll just make it bigger to demonstrate something. And let's say you bring some object. So you can see something here interesting. If you talk about the unit of measurement, we have some calibration number 0, 1, 2, 3, 4, 5. Because of the way we have calibrated the instrument, we can easily read the 2. But can we read the term beyond 2? Can you find this length?
No.
So this is called the uncertainty of measurement. Are we certain about this file? So how to write the answer? See, you will say that, see, I know the answer is 2, but there is some uncertainty, which I don't know. Okay. So I know 2, but there is some uncertainty. So it's 2 plus minus something, which I don't know.
It will be the equal to the least count.
Yeah. So now the thing is, when it is instrument, then automatically that delta M becomes the least count. We'll come to that. Okay. So this is the next part. So in context of instrument, the uncertainty is defined by the calibration itself, isn't it? So if you are writing 1, 2, 3, 4, and let's say if every term is representing millimeter, so this is 0 millimeter, 1 millimeter, this is 2 millimeter, kind of, I have zoomed the millimeter scale. So you can definitely measure 1 millimeter or 2 or 3 or 4, but you cannot measure what is between 1 and 2 or 2 or 3 or 3 or 4. So what you cannot measure? Tell me. Okay, so can you measure this? The answer is no. Can you measure this? In fact, you cannot measure this one also. Do you realize this?
Yes.
So here you're certain about 2. Are you certain about beyond 2? What is the answer?
No, sir.
So it means you cannot measure exactly the gap between 2 lines, isn't it? So once you cross the line, up to line you can measure, but beyond that you cannot measure. So what is the worst case scenario that we cannot measure? The 1 unit of calibration, right? So roughly this much we cannot measure. Isn't it?
Yes, sir.
Yes.
I mean, it is like, what is the worst case scenario? Like what we can measure? So of course we can measure when you touch the line, but even if you fail to touch the line, just before the line, we fail to measure. So there is a huge range up to which you can fail to measure because of the way the instrument is designed. So we call this as the least count. So least count having a very contradictory meaning here. So least count. Yeah, see what is the least count? So least count is defined for the instrument. It is the minimum possible so it is the minimum possible value of measurement which you can perform with that by that instrument. Okay. And every instrument will have least count, which will also act as the maximum possible deviation of the instrument, just in the limiting case. So just before the line, you can't measure. So the least count of any instrument itself is the maximum possible error of that instrument. Yes or no? Tell me, guys.
Yes, sir.
Is it possible to have 1.5 millimeter error?
No, sir.
No, because once you cross 1, the 1 is measurable. Now 0.5 is the only error. So if you have the answer 1.999999, and no matter how many 9 are right, I will fail to measure this, right? Isn't it?
Yes, sir.
So roughly I am not able to measure 0.999. So this is as good as calling 1, but it is on the lesser side. So numerically, it is least count is so you can say numerically the delta AM is roughly equals to least count, and it is always on the smaller side. So while solving question, we would take both as equal. Understood? So these are equal, the maximum possible error are equal, but are they exactly equal, or it is the limiting case of equality?
The limiting case.
And because we are solving the numerical question, so it's good to take the equality to solve numericals. Understood? So we always take the maximum possible error equals to the least count of instrument, because the least count itself is also the
Minimum possible measurement.
yeah. So it is the maximum possible error, not minimum. Maximum possible error is always the maximum, the worst case scenario. In the worst case, what you can't measure is the minimum you can measure. Very poetic. It's on the left, it's error, on the right, it's measurement. Understood what I'm saying? Okay, so LC
Yes.
is a maximum possible deviation. I mean, you can say maximum possible. So error, you can say maximum possible. Yeah, you can simply say error. So it is the maximum possible error you can have. And when it comes to the error calculation, we always look for the worst case scenario. Okay, so when you go for a, let's say, some journey, so you try to keep some pocket money for the worst case scenario. Let's say if you're going by train, and if you know the train fare is this much, but you will also keep some extra money because in case of you miss the train, you can catch the bus. So you need to have the money for the bus. But let's say there is a bus strike, so you have to go for the private car also. So you will also try to keep some contingency money for the car travel also. Okay, and then if the car is also not available, then you have to walk. Okay, that's very dangerous. The idea is when you prepare for the journey, you always prepare for the worst case scenario, isn't it? Because nothing can go beyond the worst. So in performing the experiment, when we are doing the measurement, if we know that the worst case is acceptable, then any other case will be better than that. So if you have money, which can also, I mean, let you hire the private vehicle. So your journey is, you can say, financially safe at least. Can we say this? Hello, hello.
Yes, sir.
Yes, sir.
So when you perform experiment, you will go with the worst case scenario or the best case scenario.
Worst case scenario, sir.
Because if you go with the best case and something goes wrong further, so you're trying to hit the missile to Pakistan, it goes to Nepal. Is it good? You will have bad relationship with the other neighbor country. So we need to have the worst case scenario, and if worst is acceptable, then any other case is going to be acceptable. So error is a way to kind of gauge the acceptance of the experiment. That should we go with this experiment? Are we okay? Or should we make it more accurate? Because we cannot make it 0. So only we can increase the kind of degree of accuracy, how accurate we can go. Okay, so anyway, so measurement of a physical quantity we write as the true value plus minus the delta m. The least count is for the instrument, and the least count is the minimum possible value of that the instrument can measure, or it is the maximum possible error the student can have. Okay, and therefore so the experiment you have performed A and you are getting the answer AM plus minus delta M. So we define something called what is the relative error. So what is the relative error? Guys, tell me. The error divided by true value. It is a fraction of error. And fraction is more meaningful, isn't it? So why fraction is more meaningful?
Sir, it gives
Relative
the
error,
degree
yeah.
of accuracy.
Correct. So it will tell you whether this experiment is acceptable or not. Let's say there's a mistake of measurement of 5 grams against the measurement of 1 quintal. Will you mind it? Is it so significant? Is it significant? Tell me.
No, sir.
No.
But if you are going to buy gold and there is an error of 2 grams, will you mind?
Quite a bit.
Yeah, you must mind. I mean, of course, if you're not minding, then there's something wrong with you. So a measurement of 10 grams of gold, an error of 2 grams, measurement of, let's say, 1 kilogram of some grain with an error of 5 grams. Which one is more significant, 5 grams or 2 grams? So the answer is 2 grams is more significant because the significance level we measure using the relative value, not the absolute value, isn't it? So that's why the mean absolute error is not so significant in many situations, but the relative error is very much significant. Understood? I hope this is clear. Hello, hello.
Yes, sir.
So now the last thing is called percentage error. So percentage error is when you express the relative error in percentage. So you can write as delta AM by AM into. So if you know the percentage error, you can always find the relative error by dividing by 100. Okay. Next, quickly I'll go to next concept. Okay, once you feel sleepy, you can leave the class, take a rest, watch it later on. No need to be, hanging here and not listening anything. Because I'm going to finish today itself the chapter, and I don't know how much time it will take. I'm really not sure. Okay, so now we are going to study the next concept called the propagation of error. So just like in the dimensional analysis, you study the fundamental and the derived quantities. So definitely you always measure something and then you derive something else. For example, if you want to know the volume, so do we measure volume of a cube or only side length is sufficient? Okay. So for the measurement of a volume of a cube, side length is sufficient, isn't it?
Yes, sir.
If you want to find the area of a square sheet or any rectangular sheet, you need to find the length and the width. That is sufficient. And when you perform the experiment with some instrument, the error is bound to happen because the least count is always there. So when the length will, when you are measuring the length and this is the error, this is the uncertainty which we cannot avoid. The width will have the uncertainty. Then the area is bound to have the uncertainty in the measurement, isn't it? So we can say that the error has propagated from the measured value to the derived value. Do you realize this, what I'm saying? So error will propagate from where to where? The measured value to the which value? The derived value, what you're deriving. Understood? Hello, hello.
Yes, understood.
Yes, sir.
So we have some rules which you should know. So the first is called the addition and subtraction. So to demonstrate this rule, I'll take two measurements. Let's call A. Let's make it capital A. So you're trying to measure the first quantity A, and you are getting the answer A mean with some uncertainty of value delta A mean. You're trying to measure the B, the another quantity. Of course, dimensionally they are same. And then we have B mean with uncertainty of value delta B. Okay. So now there is a third quantity which is dependent quantity on A and B physical quantity. So Z depends on measurement of A and measurement of B. Okay. So Z is another quantity which we can rewrite as Z mean plus minus delta Z mean. Because Z is the name of the quantity, physical quantity, but how we measure Z mean plus minus delta Z mean? How to write A and B? Tell me. A mean plus minus delta A mean plus B mean plus minus delta B mean. So you can clearly rewrite this term as A mean plus B mean plus minus delta M plus minus. You can change the order, that doesn't matter. So what is delta Z mean? It is the uncertainty in the measurement of Z, right?
Yes.
how we define the uncertainty? We always go for the maximum possible deviation. So what is the maximum possible value of this? What is the worst case scenario?
Delta A mean plus
Addition.
delta B mean.
So you are supposed to add only, right?
Yes, sir.
You're not supposed to subtract. And now you can compare. So what is it, ZM actually? And next time you're not supposed to do this. And what is the uncertainty in the measurement of Z? It's the sum of uncertainty in the physical quantities being measured. So you can use a phrase, and you can see something. The mean value will follow the formula, the relationship directly. So if you know the relationship of the physical quantity to get the true value, simply substitute the true value of each quantity to get the answer. No need to do this rigorous calculation. And for error, again, no need to do all this rigorous calculation. Remember the phrase. What is the phrase? Error of sum is sum of errors. Understood? Error of sum is sum of
Sum.
errors. In fact, error of difference is also going to be,
Sum of errors.
because even if you take a difference, the error is the maximum possible deviation. So I will always go for the addition, right? Yes or no?
Yes, sir.
But the mean value will follow the relationship. So ZM is, of course, so error of difference is sum of error. Okay, so I will give you some example, very famous example. So in sound chapter, there is a method called the Quink's tube method. And using the Quink's tube method, we find the velocity of sound. We write as 2F L2 minus L1, where L2 and L1 are the length at which the maximas are obtained, or you can say the highest pitch is obtained. But anyway, this is something like a formula for you. And the length is measured using some instrument, and the frequency will also have some percentage given to you as tolerance. So when you buy a commercial instrument, they don't use the word error. What they use is called tolerance. Okay. So a tuning fork will have some tolerance value. So tolerance always comes for the resistor also. When you buy a resistor, so it will have some tolerance, which is the error part. And tolerance we express in percentage. So that is the percentage error. So what is tolerance? So percentage error is the mathematical name, tolerance is the commercial name. Okay, we use the word this tolerance. Okay. So anyway, let's focus on the delta L part, the difference part. So if delta L is this much, this is the relationship. Now remember, this is the relationship. So delta L mean will be how much? L2 mean minus. So you're not supposed to do the, sorry. Just a minute. No, there's a problem. I have to remove this delta because I want to keep a variable, right? So let's call L as L2 minus L1. So L mean is how much? L2 mean minus L1 mean. And to find the error of L, we can call delta L mean. Now this is more meaningful. So delta L mean will be how much? Can you guess what we should write here? The error in this quantity is how much?
Delta L2 mean
Delta
plus
L2
delta plus
mean
delta
plus
L1.
delta L1. Correct. So to find the error, you have to, this is the error part. And you're supposed to add the error of each calculation, because the worst case will become bigger in fact now. Okay, anyway. So in the addition or subtraction, the rule is simple. the sum or the difference of errors is always the sum of errors. Okay, so we write like the d of x2 minus x1 is, so it is the matter of convenience. We drop the subscript m when we solve, because anyway we are solving only I can see, but when you're writing in the examination, you have to write properly the mean and all. Okay. When you're solving the numerical in the examination, you can just write the way you want. So after addition and subtraction, we have the multiplication rule. So when you multiply something, so I can add, okay, z equals to ab, and then okay, I'll write z later on as z mean plus minus delta z mean, but a we can write as a mean plus minus delta a mean. This is just to show you for the first time. Nothing is required like this to solve. And then you can write as, there are many terms, a mean, b mean, a mean, delta b mean, a mean, b mean. So you can see that 4 terms actually, because it's 2 by 2 product. The last term we are going to ignore. Why? It is a product of 2 error, which are small terms, right? So it's small into small, very small. So this is the first step. We ignore the 2 del terms. So the differential element, it is like if you multiply 2 differential element, it is extraordinary differential element, which you can ignore. Okay, so what you're left with now? You're left with am bm plus minus am delta bm plus minus delta am bm. And if you compare with this relation which we have understood before, then I have to write this as the maximum possible. So how to get the maximum again? It is again possible only when you make the sign between them positive, right?
Yes.
So if you compare, the z mean is basically the relation which we can get by putting the mean directly. But what is interesting here is to understand what is delta z mean. What is the delta z mean here? If you compare, it is a mean delta b mean plus, there is no minus. You can see there is no minus. Delta m b mean. Now this way of writing is not convenient. So in such scenario, when we multiply things, we try to find the relative error. So if you divide this by the z mean, what will get the answer? So what you realize? In case of product, the relative error in the term is the sum of relative errors. So in case of multiplication, the error will again add, but which error will add here? The absolute or the relative? Hello.
The relative.
Relative.
So earlier in the addition subtraction, what we add? The absolute error, right?
Yeah.
But in case of multiplication or division, actually, you'll come to know. But division is again multiplication. What you add? A relative error. I hope this is clear.
Yes.
So quickly I'll do for the division. It's the same. If you write the z equals to a by b, and of course b is non-zero, then you can write directly. I will not write the detail. Am by bm and delta z mean by z mean, you'll get the same answer. So for multiplication or division, the product or division of error is, sorry, the error of product or error of division is
Sum of relative errors.
the sum of, so I would say like this, the relative error of product or the division is sum of the relative errors, right? So in case of simply remember, in case of product or multiplication or division, simply add the value. Don't worry much. But how to add? Instead of absolute, add the relative value. I hope this will be clear. Okay. So in NCERT, there is some kind of ambiguity, like they have written, if you write z equals to, okay, I'll come to this question as a numerical only. So now comes the power. Let me finish the rule first. So if z equals to ab, what is your answer?
dz by z is dA by A plus dB by B.
Now if I put a equals to b, and if I replace z equals to a square, so it is as good as writing the terms 2 times, right?
Yes.
So can we write this as delta a mean by a mean plus delta a mean by a mean? You can write a into a, right? And then you can use the formula. And what you realize that? So when we have the power, then the power gets multiplied with the relative error, right?
Yes.
Isn't it?
Yeah.
So if it is a square, you have to multiply that. That's it. While writing the relative error, nothing else. And for getting the answer in the book. So now if I give you the question like z power p, a power a, b power b, c power c, d power d, and you can see every term is either multiplied or divided. There is no addition or subtraction. So how to write the relative error for the entire term, everything? So to find the mean value, it is very easy. Just substitute the mean everywhere. No need to worry. And therefore you got the mean. Okay, this is the answer. Now what? How to get the error part? So p times delta z mean by z mean. The power gets multiplied. Okay. And on the RHS, what we can write? A power delta m by m plus b power delta bm by bm. Now, no matter whether it is in the denominator or the numerator, it is always addition because we are doing the error calculation, not the change. So we are not differentiating actually. So does it make sense to you guys? Tell me.
Yes, sir.
In fact, based on this formula itself, you will get many questions. Okay. The next part. So after knowing all the rules, let's do some numericals. So let's say we have, 2 resistance, and you get the answer as, let's say, 5 plus minus 0.2 ohm. So the answer is 5 ohm, and the uncertainty is 0.2 ohm. And the R2 you get is 0.3 ohm. What is the error in the series equivalent? And what is the error in the parallel equivalent? Which means how to express the series and parallel given this. Tell me. Tell me quickly.
Series is 11 plus minus 0.5.
Yeah, you're saying RS1.
Yeah.
So RS will be RSM, delta RSM, right?
Yeah.
So this will be anyway 11 plus minus 0.5.
0.5.
So you can also find the percentage or relative, whatever. What about this one? How to do this question?
Same differential. One second.
Hmm. Done, guys.
2.7 plus minus 0.4.
Okay. So the mean value will be how much? RP mean will be 5 into 6 by 5 plus 6, right? So it is 30 by 11.
Yes.
30 by 11 is how much?
2.7. Two significant.
2.7.
2.7.
Okay. What is the number of significant figure in the actual question? One only.
1 only.
So how to write this in one?
Oh, so 3. 3.
No. Yeah, we have to,
3.0.
yeah, we have to round it. So this will be. So when you write the answer, you have to also take care of the significant figure also, as per the number of significant figure of the question. So it is going to be only 3, not 2.7.
Okay.
And what about the error part? How to find the error, by the way? So you can treat this as 3 terms, 1, 2, 3, and now everything is either multiplied or divided, isn't it?
Yes, sir.
So now for parallel one. So I'll tell you what NCERT prefers because this is JEE-Mains. So we are supposed to follow the NCERT, but there is one more way. I'll show you what. So you have to follow the NCERT way. So you can write as 1 by RP. 1 by R1 plus 1 by R2. So think about differentiation. So it is like 1 by R square dr. I mean, of course, you can replace d by delta, that is a matter. So what we get is this relation. So you have to differentiate in a way mentally and use the plus sign. Although you get the minus sign, but all minus must go away. So you have to make it positive. So delta RP means the error in the P upon the RP, which is the mean value. I mean, I'm not writing the mean value. The error in the first upon the R mean of square, then error in second. So as per NCERT, you're supposed to write what delta R1. What is delta R1? 0.2, right? Yeah. By 5 square. Delta R2 is how much? 0.3 by 6 square. How much is coming this? And what is the RP we got? RP we got 30 by 11, right? So this we can write as 4 by 100, so 0.8 by 100. Anyway, I mean, just keep it as it is. Okay, the values are not good, so anyway, don't worry. Okay, how much is coming after calculation? Tell me. Okay, just use the calculator and tell me the answer. It doesn't matter. So delta RP turns out to be how much? Hmm.
So should the rounding off to the one significant figure be done after all the calculations are completed?
No, no,
Or-
after everything in the last,
Okay.
not in intermediate step, never. So I think the answer is coming 0.121, right? Using calculator, of course.
Yes, sir.
So this is what I'm
Say
getting.
yes.
Yeah, got the same.
So there is no way out of apply to only 0.1, right? So the RP will be how much? 3 plus minus. So I hope this is clear. Okay. Now, what is the method 2? So we got RP equals to. So I can also write delta RP upon RP. Delta R1 by R1. Okay, these are mean values, understood kind of. So if I treat each term as single term, let's say if I take R1, R2 as one term, then everything is either multiplied or divided, isn't it? Tell me guys.
Yes, sir.
Yes, sir.
And therefore we can write like this. And then further, look this here. The error of sum is what? Sum of error. So delta of something is what? You're trying to find the error of the sum. And the answer is sum of error. Isn't it? Hello, tell me.
Yeah.
So delta R1 by R1 is 0.2 by 5, 0.3 by 6, 0.5 by 11. Sorry. Yeah, 11. So if I find delta RP here using the calci again, can you tell me the guys what is the answer? Quickly. Or else I have to do this. 0.5. And if you do so, you'll get the answer. Zero 0.369. So you can see there's a huge
Sir, I'm getting 0.144.
144. Have I made a mistake in adding? So are you using the same formula?
Sir, yes, sir. 0.3 by 6 is 0.05, right, sir?
Yeah. Okay,
Yes,
maybe
sir.
I'll just check it. My question.
Okay.
0.2 by 5. 0.04. Let me do this calculation again. 0.04 plus 0.3 by 6 is 0.05 plus 0.5 by 11 is 0.045 into 30 by 11. Am I right?
Yes, sir.
It is coming 0.369. No?
Okay, sir. Maybe I might have forgotten the brackets.
Okay. Okay, you might have added all the terms, right?
Yes, sir.
Yeah, I think this is correct. Yeah. Right. Now, when it comes, if you get a question of parallel combination kind of something like this, any formula like this, you can use either one, but because the NCERT has used this formula, I mean, it is like controversy. Sometimes the NTA will choose this formula to get the answer. Sometimes they use this formula to get the answer. What I will say is that take both method, get the answer, and then see which option is given, like which is matching. Because both will not match. I think only one will match. Okay, anyway, so it may be a bad luck if something like this comes.
Sir, but why
Okay.
do we get different answers using both of these methods?
And because see, of course, both methods are different. The first is like a differential method, like you differentiate. So first is only good or accurate if the errors are very small. So
Okay.
generally we say if the errors are less than 5%. So within the accuracy of 5%, the differential method is quite close.
Okay.
If the error is more than 5%, we should not use the differential method. I mean, that is, I think, kind of demarcation we can think about. So 0.2 by 5 is how much? I think it is less than 5%.
Yeah, 0.04.
Yeah.
4%.
And 0.3 is 5% roughly.
Yeah.
And 0.5 by 11 is also, I think, less than 5%.
Less than 5%.
So all are less than 5%, isn't it?
Yes.
So if you add all three, you will get the 15% in total. Then the total error is how much? 5%, 5%, 5%. So the RP is actually having 15% error, isn't it?
Yeah.
The relative error in RP is really huge. So I think if it is really huge, I don't think this is the right way to approach. I mean, the differential one. Differential one is used when the error is really small. I mean, but these answers are very small. Okay, I'll give you the question from NCERT. They have taken a very small fraction, like it's 0.0, like 1 upon 200. So it's a
Okay.
half percent. It's like half percent. You can think this way: if it is some fractional percentage, use differential. If it is not fractional, if it is 3, 4, 5%, I would say go with method 2. Okay. Okay, I'll stop the lecture because the page is over, and then you can rejoin after 30 seconds. Okay.